So here we have another line for which we want to calculate the gradient. Alright, let's see. But notice they did not give us any points. So it's up to us, alright, to find some points. And we all did plotting coordinates. Make sure you watch the video on plotting coordinates. Make sure you can plot coordinates. That's important. So you can identify any 2 points on this line. Now it's up to you. What is this point here? This point is what? 0, 3. We'll put it there, because 0 on the x and then 3 up. So the x is 0 and the y is 3. What is this point? It's 1 on the x, right? And how much on the y? 5 up. So this point is 1, 5. So you could use these 2 points. Or, if you wish, you could use, there's a point here, it's clear. It's clear, it's another point, just highlight this. Another point that the line passes through. What is this point? The x value here is minus 1, see? The x value there is minus 1. I say y value, all is positive 1. Before I continue though, does this graph has a positive gradient or a negative gradient? And what is the reason? Yes, the gradient will be positive because as you move from left to right, it is rising. So you always watch what the graph is doing, the line is doing, as you're moving from left to right. So when you're moving from left to right, the graph is rising. Versus if it was moving like this, it would be falling when you're moving left to right. Good? And in this case, it would be a negative gradient. But we know this one has a positive gradient, right? Because of the direction. Now, so we need to find the gradient. To find the gradient, you use any 2 points you want. Any 2 points you want. Once you have 2 points on the line, that is all you need. Because remember, we said m equal to y2 minus y1 over x2 minus x1. And it's up to you how you want to label it. Alright, let me call this x1 and y1. That means this would be x2 and y2. So if I'm using these 2 pairs, what will happen? y2, my y2 is 5. My y1 is 3, right? And then my x2, that's 1. And my x1 is 0. So I get m is equal to 5 minus 3. That's 2. It's 2 over 1. 2 over 1 is 2. Good? What if I'm using a rise over run? No. What if I'm using a rise over run? Alright? So I'm using these 2 points. So the rise, so this is the run. So the run, how far this is the run. So remember you make a rectangle, you make a triangle, sorry. A right angle triangle that is. So the run from here to here is 1, right? See, based on the marking, so from here to here is 1. So this is 1, so the run is 1. And what's the rise? It rises from 3 to 5, right? It rises from 3 to 5. Good? So the rise is 2. So the rise is 2. Right, rise from 3 to 5, so that's 2. And then the run is 1. So 2 over 1. And it's a positive gradient based on the direction. Now, what you can do is use another pair of points and see if you get the same value. You could use negative 1, 1 and 0, 3, or negative 1, 1 and 1, 5, and see if you get the same result. Positive 2 for the gradient. Now, suppose there's a line like this. Suppose there's a line like this. Let me just draw a line here. Let me just use a different color. Use blue. And let's see we have a line like this. Alright. Let me call this point A. And let me call this point B. And what if I ask you, what is the gradient of AB? What is the gradient of AB? Alright. If you want to use a rise over run, the gradient of AB, I would say slope of AB, gradient slash slope. And the very definition for the word slope should tell you what it is. Does AB has a slope? Does it have a slope? No, it doesn't. So it's 0, it doesn't slope. You good? Let us look at the formula that we use. In other words, there's no rise. If I use rise over run, if I use a rise over run formula, does the AB rise? No. AB is flat, it doesn't rise. It runs. You could say the run is what, 2? From here to here is 1, then from here to here is 2, so it runs at 2 units. But 0 divided by any non-zero number. 0 divided by 2 or any other number other than 0 gives you 0, right? Another way, if you want to use the formula, m equal to y2 minus y1 over x2 minus x1. Then if you'll notice, here the y coordinate, let's not even worry about what the x coordinates are. You see what the y coordinate is here? 1. The y coordinate is 1. What's the y coordinate here? Also 1. So the coordinate here, the x is 0, y is 1. Here, it's what? 2, 1. The x is 2. And the y is 1. So the x1 is 0. And the y1 is 1. And the x2 is 0. And the y2 is 1. So when you're doing your subtraction, y2 minus y1, the denominator, the numerator will be 0. So that you end up with 0 over the x2, take away x1. So 2 take away 0, you end up with 0 over 2. And 0 divided by 2 is 0. So it's something important to note. A flat line has what we call no gradient or no slope. So when gradient is 0, it means that the line is flat, horizontal. When it's slant like this, left to right is rising, that's a positive gradient. And in the very first example we did, we see why it was a negative gradient. Because as you're moving from left to right across the page, it falls. This one, it's rising. And that's why we get a positive gradient here of 2. Next video, we're going to look at finding the equation of a straight line.